Hello, and welcome to the My Old Car video log, where I document how I maintain, repair, and occasionally make upgrades to my 1974 Chevrolet Monte Carlo that's been my daily driver since 1984. With dedication and tenacity, you too can make your first car your forever car and drive it forever. Before I get started, if you enjoy my videos, please like and subscribe. Furthermore, this video's description may have some detailed information and useful links, and if you have any questions, please drop them in the comments. Oh God, I hate that when this happens. So, the engine's cranking and your car won't start. Now, as a mechanic, you know that there are three things that your engine needs: air, fuel, and spark. Well, the choke's working. We got air. We got fuel pump and fuel, and let's see here. Oh yeah, we got squirt. Well, that leaves spark. Just the ignition system in this car is GM's HEI. Now let's follow the manual's testing procedure. It's pretty straightforward. So the first test is to see if the distributor is getting power to the battery. Yeah, I'm sorry, if the distributor is getting power from the battery. So you turn the ignition on and check and see that yes, we do actually have power. Alright, the first test is to make sure that the distributor actually has power. I'm going to go ahead and turn on the ignition. There. Now, let's see if this thing has power. Yep, we got power. Alright, we have power. We established we have power. It says to skip to step 4, but let's look over the other steps. Number 2 is interesting. Want to make sure you have continuity between the battery terminal and then the B terminal, which goes straight to the coil. And then number 3 wants to check the check is for continuity between the ignition and the battery terminal. Now, I mean, if you're getting, and you can see where if you're getting juice, well then obviously you can go straight to step 4. Step 4 is going to check for spark. Now the easiest way that I've found, the easiest non-invasive way to check for spark is to simply use a timing light. And make sure you use one that has an inductive pickup, like this. Simply clicks on to any, there we go. I think that's the number 1, right? Yep. You just simply click it on, hook it up, and now you're not going to be testing the timing, you're actually going to be looking inside the timing light. Because you see, the way this thing works, it uses a passive inductive sensor. And then that sensor detects a current pulse that makes the spark at the spark plug. So when it detects a pulse, the light flashes, and if while cranking the engine the light doesn't flash, there's no spark. So let's see. Okay, I'm going to bring this light up so that way we can see it in the camera. Alrighty. Trigger it. Let me turn off the overhead light. There we go. Make it darker. So let's crank it. Go on. Yep. No spark. Okay, the next step is step 5, where we check for obvious issues, let's see, like cracks, dirt, moisture, and other things that could cause problems inside there, which we did, and there doesn't seem to be anything obvious. So now step 6 is to start testing things like the coil. Now, as you can see, there's a ground, and there's a primary and a secondary winding on the coil. And then this is the output from the coil. Now, you get your handy dandy ohm meter. And what you want to do is to, again, look at these things. And so let's set this to real low ohms. I'm going to set this to 200, because what we want is to be within the specs as stated in manual. So it says here we connect these two poles right here, should read greater than 1. In other words, we don't want these things to be shorting each other out. So let's see. Let's see if we set this to, probably be able to hear continuity. Yep. So that reads good. And the next test is between the output and the winding. So let's take a look here. They say should read between 6,000 to 30,000 ohms. So I'm going to set this to 200,000. Now, let's measure this, shall we? All right, we're getting 13,000 and a half ohms. Looks good. Good. And we should not be seeing anything from here or here. Should be an open circuit. But here we should be seeing, yep, 13 and a half. So that test's good. Alrighty, now come the tests of the pickup coil. So now it's time to do some tests of the pickup coil. Now it's best to do this with the pickup coil disconnected from the module. Oh, and one thing that is of note, a lot of the issues that I see with these, and again, I should point out the HEI system is really robust. I mean, surprisingly robust. I mean, they still sell it today, you know, in an aftermarket applications, you know, for hot rods and even race cars. But anyway, one of the things that I've noticed is a point of failure that's not mentioned in the manual is sometimes these connectors can become loose. And of course, once you have a loose connection, well, then you're not going to get current to flow, and you're going to have problems. So that is also a thing to check when you're, when you pull these connectors apart. How well are they working? This one I noticed, it's kind of, as you can see, kind of coming apart, and it looks like it may have gotten a little hot. So that may be what's causing this to fail. Anyway, let's go ahead and start with doing a check on the pole pickup coil. Now the pickup coil, set this to continuity here. There should not be a ground or a short of the pickup coil to ground. So what you want to do is make sure we got sound here. So we check this terminal against ground, nothing. And then we check this terminal against ground, nothing. Now we also want to do this while the advance is moving, or at least while there's advance, because for all we know, these wires could be touching when there's you know, these wires could be touching ground if something got compromised during the years that these things are in operation. So let's go ahead and set this. Come on. Alrighty, there. Nope. Nothing here. Let's try the other wire. Interesting. I'm getting some kind of a reading here. Oh, it looks like there could be some sort of a short. Alright, now according to manual, the next test is, let's see here, the actual pickup coil itself. So let's see. They say the spec for the pickup coil is between 500 to 1500 ohms. So let's set this to 2000. So this should read between 500 and 2000. Let's see. It's reading 757 I think is what I read. Here we are. It's reading 756. Now, with this moving, the vacuum advance, it should be steady. Of course, also my grip should be steady on this. Seems to be okay. Let's check other wires, if any other wires, if they get moved, something's going to be weird. Check these wires here. Doesn't seem to be. So it looks like this is testing okay. Well, what that means is we're going to need to test this module. Now there are different screws that hold that module in. This particular module is held in with 1/4-inch screws. Some are Phillips. I actually prefer these 1/4-inch because you can get a really good grip with a driver, like, you know, with a hex driver. I think that's what they call those. You know, and while you're at it, you can also test the continuity of these wires to here. So let's see. Alright, now one thing to check before you put this onto the tester is module here. Oh, let me show you what the diagram, a very rudimentary diagram of the module on the inside looks like. Okay, so looking at the schematic of the module itself, the current flows in one direction out of the pickup coil. Since this is alternating current, that means it flows this way and it wants to flow back as this flows in, and then it wants to flow back because it's alternating current. The signal converter converts it to DC through like a, what was this damn thing called, like a half wave rectifier, also known as a diode. So the current only flows in one direction to the transistor, and then the transistor is grounded here, and also the transistor will only allow the current to flow one direction. Now there are certain tests that you can do before you even stick the module onto the tester. So first, knowing that only one signal comes through here, you can do a simple grounding test on the module. So the first test we're going to do is to check the diode functionality of the transistor. Now you watch this, and you put the red lead onto the B terminal, and then the black lead onto the C terminal. As you can see, should only be about around 0.6 millivolts. Let's try this again. There you go, 0.59, that's good enough. Now if you swap the leads, it should not allow the current to go the other direction. Let's see. Yep, not allowing it, as you can see. Now, next thing you can do is check the internal ground. Make sure that all of this is going to be grounded. This is the ground terminal on these. So, we hook up the W terminal to the ground, internal ground. Make sure this system is internally grounded. And here you can see getting about 1.5 millivolts. Let's see, and it indicates that it's grounded. Now the other terminal that should be, since this is a half wave rectifier, that should not be providing any sort of ground. There, no ground, or no through. Current cannot go through because of the half wave rectifier internally. So we know that internally that this thing seems to be, the transistor seems to be okay. It's not leaking, and there is indeed, straight through ground, etc. But that doesn't tell us if the transistor is doing what it's supposed to do, which is to switch the current, to actually do the switching. So that's where the tester comes into play. Now the last thing that we need to be testing is the module. So fortunately for that, they have a special tester. And here it is. So testing the switching function of the transistor is where you'll need a module tester. And I have two here. This is edition B, this one's edition F. This is the older version than that, and they are fundamentally the same. If you look at them, you can kind of see they have like the instruction booklets, and there's a pass fail, 4-5 terminal versus 3 terminal, and it's a simple toggle switch kind of a setup. These are actually really nifty, and as things, like I said, this is the first generation, and so this can only test the earliest. Well, I shouldn't say this can only test the earliest, but they only had like the simple HEI modules available at the time. They didn't have a whole lot of exotic ones, which this one does. This one accounts for it. You can see, I showed this earlier, you can see all the different exotic I call them exotic. Anything beyond like the 4-pin stuff, I'm like, wow, that's pretty wicked. Anyway, so as GM created like the more unusual and the more exotic modules, they needed to come up with various adapters so as to adapt the newer modules, you know, onto the original testers. Because the fundamental function that these testers test is the switching function, where, you know, yes, it'll either pass or it'll fail. Now, to hook these up, oh, and one more thing. Seeing how the manufacturers were phasing out like distributor style ignitions in favor of coil on plug style systems in the late 80s, starting in the late 80s, these testers can actually be found fairly easily on a well-known auction website that I won't mention, but I do utilize quite frequently. And they're, for what they provide, they're comparatively inexpensive. I think I paid maybe $30 for this, because I got this quite a while ago, and this one was closer to $50, and I admit it was a really good deal because it came already with all of these additional adapters, which is really useful. And it even came with this this nifty spark tester, genuine AC spark tester, with the where is it? It even has its own number on here somewhere. Yeah, here it is. There goes the KNN number. But yeah, pretty nifty spark tester. You can find these all over the place. I still prefer using, I'll always prefer to use my my timing light to determine if there's spark or not. So let's get started. Now I'll go ahead and utilize the simple one here, the basic one. I'll set that, I'll put that away. I want to get a bunch of stuff here. Here we go. So you hook the power cables onto the battery first. All you need to do is just follow the instructions that are contained within the module tester. You hook those up, and then you use a known good module to test the functions. And they tell you all this stuff in here. Let's see here. They even say, yeah, do these things to verify that, you know, the tester is functioning properly. And I've already done that. There's no need to go over that because it's there. So I'm going to use this module to test. And let's see now. So this goes here. And then this connects to here. Green to green. And white to white. And you're of course going to be needing the ground. Now, the green should light, and it's not lighting. So there's something that needs to be adjusted or changed for this to work. Okay, this module is grounded through the base. So, now let's see. Pass. Now, if the ground wasn't on there, of course, it would show fail. And these eyelets don't always connect to the ground. It's just something to be aware of. Most of the modules are grounded through the base. Alrighty. Now we can go ahead and test this module. So, as before, you plug this into here, and then we plug this. You know, gotta keep track of which terminal goes where. They're pretty clear about it in the instructions. There. Now we take the ground. And there you go. Simple as that. So the module is good. Which leads me to think, as we learned when we were taking this apart, the distributor that is, that this wire must have been disconnecting or causing a weak connection. So go ahead and address that, and we should be good to go. Alright, let's see if it works now. I'll put the air cleaner on because it also functions as a flame arrestor in the event that there's a backfire through the carburetor, which, you know, I'm crossing my fingers, hope I don't have to deal with that. So, let's see. Well, what do you know? It's working. Looks like the problem is solved. One feature of the HEI system is the expanding dwell or coil saturation period. This can be observed with a conventional dwell tach, with a tach dwell meter connected to the tach terminal while the engine is running. Right here. So here we have a dwell tachometer. It's set to dwell, and it's connected to the tachometer terminal. Now, at idle, it should be about 5 to 6 degrees of dwell, and then expand up to 30 degrees at around 2,500 RPMs. So, now, this particular tachometer, or rather this dwell meter, is it measures, I mean, yeah, it has a setting for 4 and 8. It's kind of cheap. So what you do when you have 8 cylinders is that you divide this reading by 2. So if you look closely, let's see if I can steady this. It's reading at the dwell here. It's about 15. No, see, so 30, closer to 20, which you divide that by 2, and that's 10. So let's see if we can, let me see if I can, now you can see, yeah, you know, it's at, yeah, a little bit above 10. So now, let's up the RPM, and you can see how it goes up. as you saw, it went up to right there, which is around 60. And of course you divide that by 2, that gives you 30. That lets you know that the dynamic dwell, whoops, damn it. Let me try this again here. There we go. That lets you know that the dynamic saturation on this HEI module is working fine.
If you enjoyed the video and found it useful, please be sure to click the like button. Now if you'll excuse me, I think it's time for a drive.